Did you know that you, yes you, are defying the laws of classical physics every single day? If that sounds shocking, stay tuned. Because today, on this episode of Scientific Facts, we're diving into the mind-bending world of quantum tunneling, a phenomenon so strange it might as well come straight out of a science fiction movie. Buckle up because this is going to rock your understanding of the universe at its very core. Let's start with the basics. What is quantum tunneling? To understand this, we need a short crash course in quantum mechanics. Quantum mechanics is the branch of physics that studies the behavior of particles at the smallest scales. We're talking atoms and subatomic particles like electrons. At these scales, particles don't follow the same rules as larger objects. Instead, they behave like waves with probabilities attached to them. Imagine tossing a dice, but instead of getting a single number, you receive all potential outcomes simultaneously. Crazy, right? All right, here's the traditional problem physics had been facing. Say you're on one side of a big, abrupt wall, and your goal is to get to the other side. In our everyday world, if you're not strong enough to climb it or don't have the speed to jump over it, you simply fail at getting to the other side. But particles in the quantum world don't play by these everyday rules. They have a weird trick up their sleeves: quantum tunneling. In simple terms, a quantum particle can actually pass through the wall, as if the barrier didn't exist, and just appear on the other side. But how does that even work? Shouldn't that be impossible? Traditionally, yes. Think of a particle, say an electron, as a blurry cloud instead of a tiny solid ball. The wave nature of that particle describes a probability, where the particle might be at any given time. Now, when this particle encounters a barrier, the laws of quantum mechanics allow for a small probability that it can be found on the other side of the barrier. Essentially, it borrows energy to make this leap. But don't worry, it always pays it back. Because of this odd quantum behavior, the particle essentially tunnels through the wall without actually climbing or breaking through it. Mind blown? We're just getting started. Here are some solid examples to bring this surreal concept into focus. Have you ever heard of the sun? Of course you have. Well, quantum tunneling is the reason the sun even exists. When two hydrogen nuclei in the sun collide, they need to overcome a massive energy barrier due to their mutual electric repulsion, also called the Coulomb barrier. By classical physics, the temperatures and pressures in the sun's core are not high enough for these particles to fuse. Yet, thanks to quantum tunneling, these particles can pass through this energy barrier and initiate nuclear fusion, which powers the sun and provides the energy that lights up our days. And it's not just out in space. Quantum tunneling is at work in your everyday life too. For instance, in the technology used in flash memory found in USB drives or smartphones, tunneling allows electrons to pass through insulating layers to store information. Without quantum tunneling, modern tech as we know it would cease to exist. That's right. No smartphones, no laptops, no gaming consoles. Hard to imagine, isn't it? Quantum tunneling is also paving the way for potential revolutionary advancements in medical science. Take scanning tunneling microscopes, or STMs, for example. This technology uses quantum tunneling to produce images of surfaces at the atomic level. This can be crucial in biological research and drug development as it allows scientists to observe molecular structures at unprecedented detail. Think about it for a second. This means we could potentially develop life-saving drugs faster and study the mechanisms of diseases more effectively. But wait, it doesn't stop there. Scientists and researchers are also exploring the use of quantum tunneling in quantum computing. This is a subject many of you are excited about, and rightfully so, because quantum computers promise speeds and capabilities that are unimaginably superior to classical computers. Tunneling can help quantum bits, or qubits, maintain their superpositions longer, which enhances computing power drastically. Sounds like the sci-fi future we see in movies, right? Here's an even crazier thought. Tunneling plays an essential role in the fundamental nature of our world. Without it, The bonds that hold molecules together might not exist. Yep, your coffee cup or even your own body might not exist without this bizarre quantum phenomenon. So the next time someone calls quantum mechanics just theory, remind them it's the reason you're able to hold that steaming cup of coffee every morning. Despite everything we've learned about quantum tunneling, there's still so much to uncover. Quantum mechanics is a fascinating and mysterious field, and tunneling continues to challenge our inherent understanding of what's possible. Think about this paradox. If particles can tunnel, could there be a future where humans' applications of this phenomenon defy even greater odds, like teleportation? Does quantum tunneling hint that the universe is far more interconnected than we previously imagined, at a level that is almost mystical? Let's put this into perspective. Quantum tunneling reminds us that the universe doesn't always play by the rules we expect. It's a humbling and exciting realization. It inspires physicists, engineers, and dreamers to think beyond barriers, both literally and metaphorically. It's a daily reminder that maybe, just maybe, impossible is just another word for unexplored. So what do you think about quantum tunneling? Does the concept leave you awestruck, confused, or a perfect mix of both? Drop your thoughts in the comments below, and let's get a discussion started. Until the next episode of Scientific Facts, remember, the universe is stranger and more wonderful than we could ever imagine. Goodbye for now, and as always, keep asking questions. After all, that's how we tunnel through the barriers of the unknown.